Hello, my name is Maripa Babu. I am a field application scientist for molecular devices. In this session, I will review the principle behind BRET and NanoBRET applications, molecular devices, instruments that are capable for BRET and NanoBRET applications, and how to build a protocol and data analysis for these assays in SoftMax Pro. In the end, I will give you also some tips and tricks for BRET applications. Let's start with a brief introduction of BRET and NanoBRET techniques. In this representation, we see that protein A, the donor, is conjugated with a luciferase enzyme, and protein B, the acceptor, is conjugated with a fluorescence protein. As the two proteins come within proximity to each other, the energy from the luciferase reaction will excite the fluorescence protein. Over the last different years, BRET methods have been developed. All of them have their limitations and benefits, various donors and acceptor pairs, and their corresponding wavelengths can be found in the table below. In this video, we want to focus on BRET2 and NanoBRET applications. For BRET2 applications, deep blue C as substrate is used, which converts specific spectral properties to the Raniella luciferase. In comparison to BRET, it has better separated donor and acceptor emission peaks. This makes BRET2 a better choice for screening assays where a high signal-to-noise ratio is required. The NanoBRET technology from Promega is an improved BRET application. By incorporating a brighter luminescence donor, the NanoLuc luciferase, optimized energy acceptor, the halo tech, and a wider separation between donor and acceptor wavelengths, sensitivity for measuring protein-protein or protein-ligand interaction in bioluminescence reactions is improved. Regardless of the BRET methods, molecular devices plate reader can measure these assays. Now, let's get into the BRET-capable microplate reader from molecular devices. A plate reader capable for measure dual-filtered luminescence values is required. The ideal filter setup for NanoBRET will include a bandpass filter around 450 to measure the donor and a long-pass filter starting at around 610 to measure the acceptor signal. The SpectraMax ID5 with applicable filters or the SpectraMax i3X with a cartridge will fit your BRET needs. Here you can see some of the available filters for the SpectraMax ID5. Please visit our SpectraNet knowledge base on Molecular Devices website to review the complete filter list or ask our technical support team for more information. Data acquisition and data analysis for this instrument is performed in the non-expiring software SoftMax Pro. This next portion will go over protocol generation. Here's an example setting for NanoBRET detection using the SpectraMax ID5 microplate reader. In order to set these settings, select Acquisition Settings. Then select Loom Dual for dual reading. Select Endpoint as read type. In this example, we are selecting specific wavelengths and using filters for our wavelength selection. For the PMT and optic categories, we will set the integration time to 1000 milliseconds. The integration time will specify how long the instrument will spend reading each well. In the same category, we can also adjust the read height. The read height is how far from the top of the microplate the detector should be to minimize crosstalk from neighboring wells. We are using 0.67 mm as read height. With the ID5 and the i3X, read height optimization can be run prior to experiment to identify the best read height. To do so, select Pre-read optimization option found in the More Settings category. We also have a predefined protocol for BRET2. This can be found in the Protocol Manager. To access, go to the Protocol Manager in the Protocol Library and select binding and enzymology. Then select the BRET2 protocol. This will open the BRET2 protocol. Please note this protocol is developed for SpectraMax i3X. Here you can find a detailed introduction and a predefined plate. So navigate to plate 1. Then you can edit the acquisition settings as needed. For example, you can select the plate type, the plate area, or the PMT and optic settings. And if you want, you can perform the pre-read optimization option before running the initial experiment. Then click OK and start the reading. Now that we have reviewed how to generate protocols for BRET and NanoBRET assays, let's review how to execute data analysis in SoftMax Pro. For the predefined BRET2 protocol found in the Protocol Manager, data tables are already set up with correct calculations. Use the template editor to assign groups, and the data will populate in corresponding group sections automatically. To assign groups, use the plate editor. Templates can be set up before or after a run. Navigate to the template editor. In this new dialog box, you will see the plate view, groups, and assignment options. Under the Groups menu, you can edit or add groups as needed. To assign groups, select the wells, select the groups to be assigned, and select a series to label the consecutive samples. When you select series, a new dialog box will populate to provide additional information regarding your pipetting pattern and replicate orientation. Complete the series layout and sample information per your experiment and select OK. In this experiment, we create two groups, ligand and no ligand. The samples are pipetted from left to right with 4 replicates per sample. Then click OK. Now that we have assigned our wells to unique groups, let's set up the data tables. To generate data tables for ligand and no ligand groups, select the new column icon to add a formula. In the formula editor, add name and formula and then select OK. This table displays the formulas needed to calculate binding in our BRET application. For example, how to populate the raw data using the assessor well LM1, well LM2, how to calculate the ratio, the average of the ratio, and as well the statistic of your dataset. SoftMax Pro can also generate plot of the data. To generate a curve, navigate to the Graph section. Select the Plot editor. In the new window, you can select the groups to be plotted and you can select the data by using the drop-down menu. Then select OK. To adjust the fit of the curve, select the drop-down menu next to Fit and update the correct curve fit. Here, for example, the 4-parameter logistic. Below the graph, you will find all information regarding the slope or even the IC50 value and the asymptotes. Here is a NanoBRET example. The NanoBRET PPI control pair kit from Pomega was used on the SpectraMax ID5 reader equipped with the optimal filters for detection of NanoBRET donor and acceptor signals. The NanoBRET ratio versus the NuTLAN3 concentration was graphed using the 4-parameter curve fit in SoftMax Pro. Last but not least, I want to give you some useful tips and tricks for running BRET and NanoBRET applications on the SpectraMax ID5 reader. For luminescence reads, we recommend using a white flat bottom plate. Run the pre-read optimization, especially for 384-well plates and half-area plates, and use the read height optimization option. After pre-read optimization is selected in the acquisition settings and you hit read, the dialog box will populate to run optimization. Select the desired optimization to run. Keep in mind that for luminescence reads, you need to have a positive control in each of the 4 corner wells. For BRET2 assays, you can use the i3X predefined protocols that you can find in the Protocol Manager. This now concludes our BRET and NanoBRET session. In this session we have covered BRET principles, molecular devices capable readers for measure BRET and NanoBRET applications, and how to set up protocols and to perform data analysis in SoftMax Pro. Thank you for your attention.